Look at this machine carving through solid metal. How can it repeatedly perform these complex movements to manufacture the exact same component without human error? The answer lies in 3 letters, CNC, or Computer Numerical Control. This technology is the bridge that takes a design idea and turns it into physical reality. Knowing how this process works is an essential foundation for anyone entering modern manufacturing and engineering. In the automotive industry, it is responsible for the mass production of heavy-duty engine components. It is trusted to carve the flawless geometries required in aerospace engineering, and it provides the microscopic exactness needed to create life-saving medical implants. Whether making cars, planes, or medical devices, mastering CNC is the required skill to work in these high-precision fields. If you want to follow the complete journey from these basic concepts to practical machining, make sure to subscribe to Learn and Grow with Fun. Let's break down those 3 words: computer, numerical, control. First, computer. Unlike a manual tool operated by hand wheels, this machine has a dedicated, built-in computer system acting as its brain. Next is numerical. Human instructions, like a specific length or depth, are translated into pure numerical values and coordinate data. Finally, control. These specific numbers are fed directly into the motors to control the machine's physical movement. Put it all together, and CNC is a technology where programmed instructions are used to automatically control a machine tool to manufacture components accurately. Every physical part begins with a digital setup. Step 1 is the drawing. A target component is designed with specific dimensions. Step 2 is the CNC program. The program contains the instructions, telling the machine exactly where to move, which tool to use, and how fast to spin. Step 3 is the CNC controller. This acts as the interface, reading those programmed instructions and translating them into electrical commands. By handling all the measurements and movements digitally, this setup phase removes human guesswork from the manufacturing process. Step 4 brings us to machine movement. Those electrical commands physically drive the machine along its axes and ramp up the spindle rotation. Step 5 is the actual cutting process. The spinning cutting tool physically engages with the metal workpiece, rapidly removing material. Because the physical motors strictly obey the digital numbers, the cutting tool removes the exact intended amount of material every single time. Step 6 is the finished component. The physical machine comes to a complete stop, revealing a flawless, fully machined metal part. Because we use digital instructions, we achieve 3 massive benefits: accuracy, repeatability, and consistency. Let's review the workflow from idea to reality. The program leads to the controller leads to machine movement, and machine movement leads to cutting, and that cutting process ultimately yields the finished component. To summarize, computer numerical control uses programmed instructions and a control system to operate a machine accurately and repeatedly. But what exactly happens inside the machine's brain when an operator presses cycle start? We will answer that exact question in episode 3, How does a CNC machine work? Make sure to subscribe to Learn and Grow with Fun to continue your CNC learning journey. See you in the next episode.